Next, we'll talk about factoring. And the first piece of factoring is going to be factoring finding the greatest common factor. So the goal here is going to be looking at a polynomial and factoring out the greatest common factor. So before we start working with polynomials, let's actually figure out the greatest common factor of just numbers. So I want to know what is the greatest common factor of 15, 24, and 27. To figure that out, what you're thinking is, what are all the numbers that divide evenly into 15? Well, that would be 1, 3, 5, and 15. So those are all the factors of 15. Next, what are all the factors of 24? So this one has a lot. 1, 2, 3, 4, 6, 8, 12, and 24. So that would be all my factors of 24. And then for 27, all the factors of 27 are 1, 3, 9, and 27. Now that I've listed out all of the factors, I want to know what's the largest number that appeared in every one of these rows. So I think that value is 3. So my greatest common factor here would be 3. With variables, it's actually a little bit easier than it is with numbers. So the greatest common factor of x squared, y to the 5th, x to the 4th, y to the 7th, and x cubed, y cubed. Because x appears in all three of these terms, I am going to have x in my greatest common factor. For the exponent, what you want to pick is the smallest exponent that you see for x. So of the exponents 2, 4, and 3, the smallest would be 2. So that's going to be part of my greatest common factor. Because y appears in all of these terms, I am going to have y being a part of my greatest common factor. For the exponent, just choose the smallest. So of 5, 7, and 3, the smallest is 3. So my greatest common factor is x squared, y cubed. What I want to do for 4x squared minus 20x plus 16 is I want to figure out the greatest common factor of all of those terms and then actually factor it out. So the greatest common factor of 4x squared, negative 20x, or just 20x, and 16. So as far as my coefficients go, the greatest common factor of 4, 20, and 16 is 4. Because x doesn't appear in all of the terms, x is not going to be part of my greatest common factor. So the greatest common factor is just 4, which means I should be able to factor it out. So to factor it out, I'm going to divide each piece by 4. For my first piece, I'm left with x squared. Next, I'll have minus 5x, so 20 divided by 4. And then lastly, 16 divided by 4, which is 4. And you can always go back and double check yourself, right? I mean, you should be able to distribute and get right back to where we started. Next, let's figure out the greatest common factor of 25x to the 4th, 15x cubed, and 20x squared. Let's factor it out and then write this as a product. So just starting with my coefficients, 25, 15, and 20. The largest number that goes into all three of those would be 5. Since x does appear in all three terms, I am going to have an x in my greatest common factor. For the exponent, I'll just choose the smallest. So 4, 3, and 2, the smallest was 2. So my greatest common factor is 5x squared, which means we're going to divide each piece by 5x squared and factor it out. So for my first one, 25x to the 4th divided by 5x squared should give me 5 and then x squared. Remember, when you divide with the same base, you subtract the exponents. Next, negative 15 divided by 5 is negative 3. And x cubed divided by x squared is just x. So I subtracted my exponents again. And lastly, the x squareds cancel, 20 divided by 5 is 4. So I factored out my 5x squared and got 5x squared times 5x squared minus 3x plus 4. Now let's do this one. So I want to figure out what's the greatest common factor of 3x cubed y squared z, 5x to the 4th y cubed z to the 5th, and 4xy to the 4th. The greatest common factor of 3, 5, and 4, well, they actually don't have any factors in common except for 1. X appears in all of these terms, so x is going to be part of this. As far as the exponent goes, the smallest exponent on x is 1. Y appears in all of them, so y is going to be part of this. Looks like the smallest exponent on y is 2. Z does not appear in all these terms, so z is not part of my greatest common factor. So I'm going to write my answer down here since we are running out of room a little bit. So my greatest common factor was x y squared, which means I should be able to divide each of these terms by xy squared. For my first term, when I divide this out, I'm going to be left with that 3. I'm getting rid of one x, so I'm left with 2 of them. The y squareds cancel, and I still have my z. For my next term, I still have the 5. We're canceling out one x, so I'm left with 3 of them. Canceling out 2 of my y's, so I'm left with one y. And we're not canceling out any z's. And my last one, the 4 stays. I've canceled out the x's, and I've canceled out 2 of my y's, so I'm left with y squared. So we factored out xy squared and rewrote this as a product.